Yo, what's up, family? Happy Friday, man. We made it through another week of productivity. I appreciate you guys getting on and doing your work. So we're at day three, which is going to be, about the same length as it was yesterday. And sorry about the confusion on the video, but like I always say, man, if it's not a good day if I'm not making a mistake, you know what I mean? So don't always just go off of what I say, go off of what I'm teaching you and what you know, and just double check. And then if you have a problem, then you can email me or whatever. But just don't just take my word for it right away, because I make a lot of mistakes all the time. But anyway, we're at week 7, day 3. Distance on a coordinate plane, right? We're supposed to calculate distance on a coordinate plane. So this first picture, it says determine which expression best shows the distance between the 2 points, right? And so if we look at number 1, it has 7 minus 1, 7 minus 3, 1 minus 3, and 1 minus 1. So if we count the dots here from dot to dot, we have 1, 2, 3, 4. So there's 4 spaces in between, right? There's 4 spaces, 1, 2, 3, 4, right, on either end. So the one that best represents this would be 7 minus 3, which equals 4. So 7 minus 3 equals 4 is the expression that best shows the distance between the 2 points. Because there's 4 here, and then 7 minus 3 is 4. So one thing, I wish I was in a classroom that was able to show you that if they're in the different quadrants, you're going to subtract. But if they're in the same quadrant, you're going to add. But either way, it's all the same. So I don't even want to confuse you with that. So anyway, you just count the distance between the dots here. You just count the distance between the dots. And then you choose the answer that would be equivalent to whatever this is right here. So for number 1, you should check B. Okay? All right. Number 2, there's only one space, one space, right? There's only one space in between these 2 dots. So the one that best represents this would be 4 minus 3. And you say, well, 2 minus 3 is -1, but when you're calculating distances, you never have negatives. It's always like the absolute value. And remember, we talked about absolute value only being a positive number. Unless the negative is on the outside of the absolute value, then it's associated with it. All right, so the one that goes with that is letter A. Letter A, 4 minus 3 is 1. All right, number 3. So how many spaces are there between the dots? That looks like 1, 2. That's 1 and then 2 on the dot. Okay, so 4 minus 2 would be the best one because 4 minus 2 is 2, and there's 2 spaces in between the dots. All right, so far so good. Pretty easy. Pretty easy. Hold on, let me scroll up. All right, number 4. Number 4, we can count. We can count, and that's going to be 1, 2, 3, 4, 5. Right? So we counted 5, and that looks like the one that best describes this is 9 minus 4 is 5, so that would be C, because there's 5 spaces, and 9 minus 4 is 5. Okay, number 4. All right, number 5, man, we're moving right along, you guys, nice and easy. So that looks like 1, 2 spaces again. There's 2 spaces there, and so the best one that represents it is letter C. 5 minus 3 is 2. Yes, 3 minus 5 is -2, but again, we don't have negatives when we're counting distance between points because there's no negatives. It's always positive. All right. Number 6. Looks like we got 1, 2, 3, 4, and 5. So there's 5 spaces in between, and the one that best represents that would be letter D. 7 minus 2 is 5. All right. Pretty easy, pretty easy. Moving right along, you guys. Right along to the next set right here, 7, 8, and 9. All right. So I'm not going to say which one it is, but you can tell me with your answer. So we're just going to count 1, 2, 3, 4, 5, 6, 7, 8. Okay. So we could do process of elimination. It's 8. It's not going to be B because that's 9 minus 0. And it's not going to be C, and that's 0, 0 minus 0. Again, it can't be D because there's no negatives. So the only one it could be. You got it. All right. Number 8. Count how many? 1, 2, 3, 4, 5, 6, 7. All right. Which one best represents that? Okay, very good. Number 9. 1, 2, 3. Oh, make sure that's 3. 1, 2, 3. Okay. All right. So which one best represents that? All right. So hopefully you guys got that. 789. That's it. All right. Pretty basic. All right. So now let's look at this part. And it says, use this picture, which is right here, to answer A, B, C, and D. Answer those questions. They will be separate questions that are true and false questions. Okay, so we have to look at this picture, read the questions, and determine which one is right or which one is wrong. All right, so it says for letter A, Andre is closer to Maria than to Simone. So if we look at Andre is here, and then is he closer to Maria or is he closer to Simone? And we could kind of look and see that he might be closer to Maria, but we don't know. So let's just count. 1, 2, 3, 4, 5. So he's 5 spaces away from Simone. He's 5 places away from Simone. And he's 1, 2, 3, 4 spaces away from Maria. So the question said, Andre is closer to Maria than to Simone, and that should be true. That first one should be true. Okay? Letter B. The distance between Cody and Amber is 6 units. All right, well, let's see. So this is Amber, and this is Cody. The distance between the two of them is 6 units. Let's see. 1, 2, 3, 4, 5, 6, and 7. So it is not. That is false because the distance between Amber and Cody is 7 units, not 6. Count it again. 1, 2, 3, 4, 5, 6, and 7. Okay, so that is false. Letter C. The distance between Maria and Cody is equal to the absolute value of -4 plus 3. So we know absolute value is always what? Positive. Okay, so we have absolute value of 4. That means that's the distance from 4 to 0 is 4 spaces, right? So that's going to be the equivalent of 4 plus 3 is 7. So the distance between Maria and Cody is equal to 7. So let's see. Maria and Cody. Let's count it. 1, 2, 3, 4, 5, 6, 7. So that is true. The distance between Maria and Cody is equal to the absolute value of -4 plus 3, and that is correct because it is 7 units. And the last one, letter D. Maria's desk is a reflection. Now we have to think about that word, so just hold on to that right there. A reflection of Andre's desk over the y-axis. And so what that is saying is when anything is a reflection, it is the mirror of the same thing. But it's only a mirror. You see how we have Amber and Cody? That's a reflection, but it doesn't match. So even though they're on the opposite side of the y-axis, right, and they're on the same number line, it's not a reflection because it would have to be the exact same distance between the two. Does that make sense? I hope that does. All right, so the question is reflection of Andres and Maria. So let's count them. So they're on the same line. You can see that they're on the same line across or over the y-axis, but let's see the distance. We got 1, 2 right there, and then we got 1, 2 right there. So yes, that is true that Andre and Maria's desk are reflections of each other over the y-axis. So yes, that is true. All right. Pretty simple, you guys. This is pretty simple. I love this type of math because like you get to kind of like, it's almost like reading a map, almost. All right, we're almost done, family. Happy Friday. So it says use this picture for the last few questions. Read the instructions on the picture. So these questions, right? You will need to draw your own coordinate plane. So you got to draw your own coordinate plane on your paper. It should look like the one in the picture. Once you have done this, read the questions and see if your order pairs match those in the true or false statements. Those are some great instructions, Mr. B. Why, thank you, Mr. B. Use the description, right, to plot each location on the map of the school. So this is the map right here. This is what we'll be using. And then we have to read these questions and interpret them on our graph. But you have to recreate your own graph. Okay, so that means you have to get your paper out and draw the coordinate plane, and you have to start and end at -5, 5 and -5 on the x, and 5 and -5 on the y. All right. So it says the office is located at the origin, and remember the origin is right in the middle. Okay, so I'm going to draw mine right here. All right. So we're going to have our coordinate plane. Okay, we have our little spaces going up to 5. Okay, and then we label it. This is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. -1, -2, -3, -4, -5, and -1, -2, -3, -4, -5. So we have just drawn our coordinate plane. If you want, you can box it in if you want. That's fine. Okay, so that's our coordinate plane. And remember here, this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay. All right. So let's see. The office is located at the origin, and remember the origin is always right here in the middle at 0, 0. So we can call this the office, just like the TV show that you guys like, The Office. Okay. All right. The next one says the computer lab is located at -4, -3. So remember, we go over, this is the x, and then this is the y. So we go x first, and then y second. Okay, so we go over 1, 2, 3, 4, -4, and then -3. 1, 2, 3. So this is going to be, we could just say CL for computer lab. Okay, CL for computer lab. All right, and we'll go back and look at the questions in just a moment. The library, it has the same coordinate as the computer lab and a y coordinate of 1. So it has the same x, which is 4, and then a y coordinate of 1. So that means this is going to be where the library is. So we'll say LB for library because it has the same x and then a y of 1. Okay. The art room is 1 unit right and 4 units up from the library. So 1 unit right is here, and then 4 units up. 4 units up is where the art room is. So 1, 2, 3, 4. And so we could just say right here AR for art room because it was 1 unit to the right. This will be continuing to the left, and this is to the right. So it's 1 unit to the right and then 4 units up. That's the art room. The next one, the reflection. Remember that reflection we talked about of the art room across the y-axis is the location of the cafeteria. So if we go the reflection, remember the reflection has to be the same thing across the y-axis. So that one is going to be 3, 4. That one is going to be 3, 4, and that is where the cafeteria is. So that's where the cafe is, right? So over 3, up 4, same thing, over 3, up 4. They are a reflection across the y-axis or across the x-axis. So in this case, it went across the y, okay? And the last one, the gymnasium is 9 units down from the cafeteria. So we know where the cafeteria is, right? And so we're just going to count 9 units down. So that's going to be from the cafeteria, 1, 2, 3, 4, 5, 6, 7, 8, 9. But it stays on the same line. So that's going to be -3 and 5, -3, -5. And this is where the gym is. Okay. So now that you have those answers, right, you can answer these questions, right? Like all of these questions are true or false. And since you already have your responses, then you can answer these questions, all right? And that's it, man. We are done for this week. Next week, we are going to be jumping into a little bit of multiplication, division type stuff. We're talking about greatest common factors and common denominators and, you know, least common multiples and, you know, all that kind of stuff. But should be fun. All right, man. Until then, you know what I'm saying? Be blessed. Have a great weekend. Get some of that sunlight. And remember that I love you. All right. Peace.